Okay, so I sent you two articles I read. One about the dynamics of how frisbee flies, and one about arrowfish, which are fish that can hover above water. And so I found some similarities between the two articles, and I would like to discuss the two and compare with each other. So the first one about frisbee is more of not exactly an article, more of an explanation of how to fly frisbee and how to practice it. But it also talks about the physics of how frisbee flies. So the basic idea is when you throw a frisbee, it creates a low pressure underneath the frisbee and a high pressure above it. And this pressure difference creates a force, because force equals pressures time the area the pressure acts on. So you get the lift, because the difference between the pressures are between the bottom and top, so it creates a lift upwards. So this is the basic physics of how frisbee flies, because the lift force opposes the gravitation force that acts on the frisbee, which equals the mass of the frisbee time the gravitational constant. So together the two forces oppose each other, and if the lift is higher than the gravitational force, the frisbee stays up. So that's basically it. And the similarity between the frisbee and the fish is that the fish wings acts actually quite similar to the frisbee, because the all represents some kind of a wing. So the second article I sent you about the fish talks about how the fish hovers above water, because you may get to see that sometimes fishes are jumping outside of the water and hover a little bit. Maybe in the Sea of Galilee, I saw it. And so what the researchers did with the fish in the second article, they used some dead fish and fill it so it would resemble the original fish, like near its size, and they put it in an air tunnel. So you have like a puppet of fish, which is nearly identical to the fish in the water, and they put it in this air tunnel and saw the effects of the wind on the fish. So there is a wind blowing for one direction and the fish facing the other direction, and saw how it flies, like if it came in an angle with the wind, or if it was straight with the wind. And actually they conclude that when the fish was horizontal, like the same direction of the fins of the fish were the same direction of the wind. So the fish actually flew this way the best. So when the fish is actually parallel to the water and hovers just above it, it can go for the longest distance instead of in an angle or upwards or downwards, which is very similar to the first article with the frisbee, which talks about the angles of throwing the frisbee. It says in the first article that the frisbee that was thrown in a straight line actually flew the furthest distance, and it was most stable, and you can actually kind of predict where it would land if you practice it enough. And so throwing in a straight line was the best way to throw the frisbee. And also did the researchers find about the fish that hovering in straight line was the most efficient way for the fish to travel. Actually, I would like to talk about a little more about the second article on the fish. It was a kind of a revolutionary research because researchers always assumed how fishes fly, how fish flies. They kind of assumed that the fins were acting as wings, and the dynamics, which is similar to just wings, opposes wind. And what was revolutionary, it was actually demonstrating how the wind affects this specific airfish. So what was revolutionary was to actually that they took the dead fish and fill it, so it was similar in dimensions to the original fish, and put it in this air tunnel I mentioned before. So that was the revolutionary part. So they could really examine each part of its flying, opposing the earlier statement that they just assumed how this dynamic worked. They assumed it was like other gliding animals. So they could really examine this.